If this quadratic equation is written in the form y equals a times x minus h, the quantity squared plus k, we can quickly and easily graph it because we'll know what the vertex is, what the range is, and we could do it very, very quickly. But we're given y equals x squared minus 4x plus 5, and it's not in the right form. So I'm going to try and do what we did earlier, which was complete the square. And the first thing I did was move the constant to the other side of the equation. So I'm still going to do that. We now have y minus 5 is equal to x squared minus 4x. Our second step in completing the square was grouping our x's. And at this point, if you wanted to, you can also group your y's. Then we were supposed to take out the leading coefficient, but there is no leading coefficient. So our next step was to try and bring out the exponent 2. We would still have y minus 5 is equal to, x comes down, the sign comes down, and half of this other coefficient comes down, and half of 4 is 2. But recall that this 2 squared is new, and it's a negative 2 squared, which is still positive 4. So in order to keep an equal sign, to keep a balance, we need to add 4 to this other side of the equation. So we now have y minus 1, negative 5 plus 4, is equal to the quantity x minus 2 squared. So again, if we wanted to put it in this form, it says y equals y all by itself. So we need to get rid of this negative 1 we put over here. So we can add 1 back to that side and add 1 to this side. We now have y equals the quantity x minus 2 squared plus 1. So from this we can read off our vertex. Our vertex is the point found inside here with x. It's a negative 2, so I use a positive 2. And the number on the outside, use it as it is, a positive 1. And they also want the range. Well, the range, because the leading coefficient is positive, is going up. So our range will go all the way up to infinity. And where does it start? It starts at this number by itself. It starts at 1. So if I was to graph this, I would go to the point positive 2, positive 1. And I know that I'm going up on both sides. So we could plot points to try and get these exact values, which is what I do suggest doing on the test. And I know it goes through this point and this point. What's another point that it goes through? So let's make a little XY table. And the numbers that I would put in this XY table are numbers around our vertex, the line of symmetry. 2 goes in the middle of my list. I go a little smaller, 1 and 0, and 3 and 4. So when I put in 0 into the original equation, I get 5. So it went through the point 0, 5. And since we know about the line of symmetry, we know that it's going to be the same on the other side. So at 4, it also goes through 5. And then we put 1. We can either put 1 in the original equation and work it out, or we could put 1 in this new form. 1 minus 2 is negative 1. Negative 1 squared is positive 1, plus 1 more is 2. So it goes through the point 1, 2, which is that point right there. Our vertex, we already know, is 2, 1. And because our line of symmetry is going to be the same on both sides, we know that this will go through 3, 2 as well. So there is your graph and all the required information.